Today we are going to learn about sentiment analysis with Python, a beginner's guide. We'll explore how to perform sentiment analysis using Python's powerful libraries, build a basic sentiment analysis pipeline, and evaluate its performance.
Welcome to our video on sentiment analysis with Python, a beginner's guide. Sentiment analysis, also known as opinion mining, is a process of computationally identifying and categorizing opinions expressed in text to determine whether the writer's attitude towards a particular topic is positive, negative, or neutral. This technique is widely used in various fields such as marketing, customer service, and social media analytics to gauge public opinion and make data-driven decisions. In this video, we will explore how Python, with its abundant libraries and tools, facilitates effective sentiment analysis. We'll delve into setting up the Python environment, utilizing NLTK for basic sentiment analysis, implementing text preprocessing techniques, building a simple sentiment classifier, evaluating its performance, and visualizing the results. Let's get started.
In this segment, we'll delve deeper into the concept of sentiment analysis. Sentiment analysis is the process of determining the emotional tone behind a series of words to gain an understanding of the attitudes, opinions, and emotions expressed within an online mention. It's a valuable tool in several industries. For instance, companies use sentiment analysis to understand consumer feedback and improve their products, while political analysts might use it to gauge public opinion on policy changes. Despite its importance, sentiment analysis is fraught with challenges. The subtlety of human emotion, sarcasm, and context can make it difficult for algorithms to accurately interpret sentiments. Python comes into play as a powerful tool that can help tackle these challenges with its vast array of libraries designed for text processing and machine learning. A typical sentiment analysis pipeline involves several steps: data collection, text preprocessing, feature extraction, sentiment classification, and result visualization. Each step is crucial in ensuring the accuracy and effectiveness of your sentiment analysis efforts.
Before we dive into coding, it's essential to set up our Python environment properly. First, ensure you have Python installed on your system. You can download it from the official Python website. Once you have Python installed, it's a good practice to set up a virtual environment. Virtual environments help manage dependencies for different projects, ensuring that each project operates in its isolated space without conflicts. You can create a virtual environment using the vend module, which is included with Python. Next, we'll need to install some essential libraries for sentiment analysis. NLTK, or Natural Language Toolkit, is a powerful library for working with human language data. Install it using the command pip install NLTK. Additionally, libraries like pandas, matplotlib, and scikit-learn will be useful for data manipulation, visualization, and machine learning tasks. If you encounter any installation issues, ensure that your Python and pip versions are up to date. With our environment ready, we're set to explore sentiment analysis techniques in Python.
NLTK, or Natural Language Toolkit, is a key library when it comes to processing textual data in Python. It offers a suite of text processing libraries for classification, tokenization, stemming, tagging, parsing, and more. To start with sentiment analysis using NLTK, we need to understand some basic concepts. Tokenization is the process of breaking down text into individual words or sentences, which can then be analyzed. NLTK provides a simple way to tokenize text using its word_tokenize function. Another important concept is stop words, which are common words that don't contribute much meaning to the text, like is, and, the. NLTK has a built-in list of stop words that we can use to filter out these words from our analysis. For sentiment analysis, NLTK provides a sentiment intensity analyzer through its Vader_lexicon. This tool is specifically attuned to sentiments expressed in social media. A practical example would involve inputting a sample text and using the sentiment intensity analyzer to get the polarity scores, which range from -1, most negative, to 1, most positive, and the subjectivity score, which indicates the level of personal opinion present in the text. Text preprocessing is a critical step in sentiment analysis. It involves cleaning and preparing raw text for analysis, ensuring that the data fed into machine learning algorithms is meaningful and accurate. The first step is tokenization, where we split the text into words or sentences. Following tokenization, we often apply stemming and lemmatization. Stemming involves reducing words to their root form, for instance, running becomes run. Lemmatization, on the other hand, reduces words to their base or dictionary form, which is more sophisticated than stemming. After stemming and lemmatization, we remove stop words, which are common words that don't add significant meaning to the text. Text normalization is another important process. It involves converting text to lowercase, removing punctuation, and handling special characters. All these steps help in reducing noise in the data and improving the performance of our sentiment analysis model. A typical preprocessing pipeline might start with tokenization, followed by stop word removal, then stemming or lemmatization, and finally normalization. By ensuring that our text data is clean and well prepared, we set a solid foundation for accurate sentiment analysis. Now that we have our text data preprocessed, it's time to build a sentiment classifier. A sentiment classifier is a machine learning model that categorizes text into positive, negative, or neutral sentiments. The first step in building a classifier is choosing the right algorithm. Common algorithms for text classification include naive Bayes, support vector machines, and logistic regression. For beginners, naive Bayes is often recommended due to its simplicity and effectiveness. Next, we'll need a labeled dataset, which is a collection of text samples that have been manually categorized by sentiment. This dataset is used to train our classifier, allowing it to learn the patterns associated with each sentiment. In Python, the scikit-learn library is a popular choice for implementing machine learning models. It provides a simple interface for training and evaluating models. We'll use scikit-learn to implement a basic naive Bayes classifier. After training our classifier on the labeled dataset, we can test it on new text samples to see how well it performs. The output of the model will indicate the predicted sentiment class for each input text, allowing us to analyze and interpret the results.
Evaluating the performance of our sentiment classifier is crucial to ensure its accuracy and reliability. Several evaluation metrics are commonly used to assess model performance. One of the most fundamental metrics is the confusion matrix, which provides a summary of the prediction results on a classification problem. It shows the number of correct and incorrect predictions, categorized by the actual and predicted classes. From the confusion matrix, we can derive other valuable metrics like precision, recall, and F1 score. Precision indicates the accuracy of the positive predictions, recall measures the model's ability to find all positive samples, and an F1 score is the harmonic mean of precision and recall, providing a balance between the two. These metrics help us understand how well our model is performing and where it might be falling short. For instance, a high precision but low recall indicates that the model is very precise when it predicts a positive sentiment but misses many actual positive cases. By interpreting these evaluation results, we can make informed decisions on how to improve our model, such as by adjusting its parameters, or improving the quality of our training data. Visualizing sentiment analysis results provides a clear and intuitive way to understand the data and the insights derived from it. Data visualization helps in identifying patterns, trends, and anomalies that might not be immediately apparent from raw data. Python offers several libraries for creating compelling visualizations. Matplotlib is a widely used library for creating static, interactive, and animated visualizations in Python. Similarly, Seaborn is built on top of Matplotlib and provides a high-level interface for drawing attractive statistical graphics. With these tools, we can create various types of charts and graphs, such as bar charts, pie charts, and line graphs, to represent sentiment analysis results. For instance, a bar chart can be used to show the distribution of positive, negative, and neutral sentiments across a dataset. Once we have our visualizations, interpreting them is key. For example, a sudden spike in negative sentiment in a line graph could indicate a specific event impacting public opinion. By effectively visualizing and interpreting sentiment data, we can derive actionable insights that inform decision-making processes in fields like marketing, product development, and customer service.
Enhancing the accuracy of our sentiment analysis model involves several practical strategies. The first step is to ensure high-quality data. This means having a well-labeled and diverse dataset that accurately represents the sentiments we aim to classify. Feature engineering is another critical aspect. It involves selecting and transforming the most relevant features from the text data to improve model performance. Techniques like n-grams and TF-IDF, term frequency and verse document frequency, can be used to capture more context and meaning from the text. Handling imbalanced datasets is also crucial, as having a disproportionate number of samples in different classes can skew the model's predictions. Techniques like oversampling, undersampling, and using synthetic data can help balance the dataset. Hyperparameter tuning involves adjusting the parameters of the model to find the optimal settings that improve its performance. Tools like grid search and scikit-learn facilitate systematic hyperparameter tuning. Lastly, continuous model evaluation ensures that the model remains accurate and reliable over time. Regularly updating the training data and retraining the model helps in adapting to new trends and changes in language use, maintaining its effectiveness in sentiment analysis tasks.
For those looking to delve deeper into sentiment analysis, advanced techniques like deep learning offer powerful tools for more accurate classifications. Deep learning models, such as neural networks, have the ability to learn complex patterns in data, making them particularly suited for tasks like sentiment analysis. Within deep learning, long short-term memory, LSTM, networks and convolutional neural networks, CNNs, are popular choices for text classification. LSTMs are a type of recurrent neural network that excels at learning sequences and dependencies, which is crucial for understanding the context in text. CNNs, traditionally used for image processing, have also shown great promise in text classification tasks by capturing local and position invariant features. Another exciting development in sentiment analysis is transfer learning, where pre-trained models like BERT, bidirectional encoder representations from transformers, are fine-tuned on specific tasks. These models have been trained on vast datasets and can be adapted to sentiment analysis with minimal additional training. By leveraging these advanced techniques, we can greatly enhance the accuracy and robustness of sentiment analysis models, opening up new possibilities and applications in fields like AI-driven customer service and real-time sentiment monitoring. As we conclude our beginner's guide to sentiment analysis with Python, let's recap what we've covered. We've explored the basics of sentiment analysis, set up a Python environment, used NLTK for basic analysis, implemented text preprocessing techniques, built a simple sentiment classifier, evaluated its performance, and visualized the results. Sentiment analysis is a powerful tool with applications in various fields, from marketing to politics, providing valuable insights into public opinions and trends. As you continue your journey in sentiment analysis, I encourage you to experiment with different datasets, algorithms, and techniques to enhance your understanding and skills. There are numerous online resources, tutorials, and courses available to further expand your knowledge in this exciting field. Thank you for joining us in this introduction to sentiment analysis with Python. We hope this guide has provided you with the foundational skills and inspiration to explore deeper into the world of sentiment analysis.